Today we will learn about composites and see where they are used on Webb campus. Let's go! Oh look, a bunny! Welcome to the Yacht Club. I wonder what we can find here.
Composite materials are made of two primary components called the matrix and the reinforcers. The matrix is the base material, and the reinforcers are any kind of particle or fiber placed in the matrix to strengthen it.
It looks like we have some reinforced concrete. Now we will learn about concrete with Payne Donaldson. Rocks!
Aggregate composites, more commonly called concrete, are made of a cement matrix and reinforcers of sand and gravel. Concrete has many different sized particles. The cement matrix is mixed with water, and then the cement reacts with the water to set, and this process can take up to 30 days. Concrete is strong only in compression. This is why it makes an ideal material for roads or piers. Concrete is also very cheap. Concrete's engineering tensile strength is effectively zero. To compensate for this in construction, reinforced concrete is used. Concrete is reinforced with steel bars, which can be seen in these core samples, which allow the concrete to take high tensile loads. Concrete can either be pre-stressed or post-tensioned. In pre-stressed concrete, the steel bars, as can be seen here, are held in tension as the concrete sets. Then the rods are untensioned, and this puts the concrete in compression. In post-tension concrete, concrete is set around hollow tubes, seen in blue here. Steel cables are placed in these tubes after the concrete sets, and then the cables are tensioned and anchored to the edges of the concrete. This also puts the concrete in compression.
Here we have our lightweight, high-performance boats.
Fiber-reinforced composites are made of very strong, stiff fibers and a ductile matrix. The matrix protects the fibers and transmits the force to the fibers, which carry the load. Some of the most common matrix materials used in fiber-reinforced composites are epoxy resin and polyester resin. Some common fiber reinforcements are fiberglass, carbon fiber, and Kevlar. There are several ways that the fibers can be configured, each with their own strength properties. Fibers can be unidirectional, chopped, or woven. The weaves can be of different sizes as seen here. The thicker weave has a higher fiber density when laminated in the resin. These materials are frequently used in boats like this rowing shell due to their high strength and relatively low weight. Fiberglass can be molded into a variety of shapes and offer great versatility in construction and repair. The fibers only provide strength in the direction they are oriented and can achieve high tensile strength while still being very thin and flexible, as you can see as we apply a load perpendicular to the surface of this boat hull. To reinforce these very thin walls, boats are constructed with stiffeners on the inside of the hull, as can be seen here.
No composites at the garden. Let's keep looking. Welcome to Haverly. Let's take a closer look at these composite samples.
Here we have woven carbon, unidirectional fiberglass with all layers going in this axis, and alternating layered fiberglass with fibers going in two different directions. Here you can see half the fibers going in the major axis and half going across the piece.
Welcome to the wood shop. I wonder what we'll find here.
Aluminum oxide!
Particulate composites are characterized by a large number of hard, reinforcing particles in a softer matrix. Commonly, these materials consist of ceramic particles in a metal matrix. Particulate composites are often used as cutting tools and abrasive materials. For example, here we have aluminum oxide sandpaper.
Here in the student garage, we find plywood, which is laminar composite.
Laminar composites, like plywood, have alternating grain directions between the layers. This offers strength in multiple directions.
Thank you for joining me in exploring Webb Campus and learning about composites. Please like and subscribe.
Cool.